Hi, in this video we're going to do some work with rational expressions. We're going to simplify complex fractions, factor, polynomial expressions, and rational expressions, and then simplify using maybe division techniques. When you want to simplify a complex fraction, you want to find the least common denominator, multiply each term by the least common denominator, and then simplify the result. So the least common denominator, well, in this particular term, we have a 1 for a denominator, so we only have two denominators to look at here. That is the x plus h and the x. These are two different things. Let's say x was 3. This would be like 3 plus 4, maybe 7. This would be 3. Those are totally different numbers, right? So the LCD for this problem would be x and x plus h. We have to multiply those together. And when I multiply them, I do it times every single term in the problem. And I can put it over 1 if it's helpful to make sure I don't get it messed up or where I know exactly where it is. So for the first one, the x plus h's are going to cancel. And you get x times 1, which is x. For the second part, the x's cancel, and you get x plus h, but there's a minus in front of that, so you get minus this expression. You have to remember to distribute the negative through there. And for the last part, you just get xh, x plus h. Okay? And then I'm going to simplify this top, distribute the negative, negative x, negative h. And finally, x minus x, those are additive inverses. So I'm left with negative h. But look what happens. Now I have a standalone h on top and bottom. So those also are going to cancel. Remember, when you cancel something, it doesn't go to 0, it goes to 1. So my final answer here is going to be negative 1 over x times x plus h. All right, the next one is a little different because I've got radicals in there, but the same idea. I still have the denominator is 1 here for that h in the denominator. And so what I have, instead of having x and x plus h, I have the square root of those things, but it's very similar to the last problem. The least common denominator is this one and this one. I can write it, you don't have to write it every time. You could write it once, but I like to put it next to all of them so I don't forget what I'm doing. Okay, so what happens here is the x plus h cancels. Here the square root of x cancels. So what I have left is that square root of x minus, and I have the square root of x plus h. And down here I have the h and then the square root of x and the square root of x plus h. Now, in this particular problem, up here it was nice because we could just distribute that negative, but you can't do that here. And so if you want to clear out the radicals in the numerator, you multiply it by its conjugate. Now the conjugate is the same exact thing with a different sign. So I have the square root of x, and I have the square root of x plus h, but instead of a minus, I have a plus. And of course, like any other fraction, if I multiply the numerator by something, I have to multiply the denominator by the same thing. When you have these things, which are conjugates, same terms, but one's a plus and one's a minus, your inside and outside terms of the FOIL are going to drop out because this is going to be a negative and this is going to be a positive of the same thing. So all I have to worry about are the first terms and the last terms. So that anytime that you have a square root times itself, you get the radicand. So that's just going to be x. Be careful because I have a minus and a plus, so that's going to be minus. And then I get a square root times itself again, so I get that radicand. And now on the bottom, I have all this junk. I'm going to call it junk, but all this stuff. And h and the square root of x and the square root of x plus h and the square root of x plus the square root of x plus h. Hey, I didn't write this one. So don't blame me because it is messy. Now I have x minus x again. This is just like what we had up here, right? I have x minus h over all that stuff. And now x minus x is gone. I have negative h over h square root of x plus h, and all this stuff. And finally, I can see again that I can get rid of that h, and that gives me a negative 1 over square root of x plus h, square root of x plus the square root of x plus h. Phew. All right. That's simplifying complex fractions. Let's take a look at one more simplifying complex fractions. This is was 3G on the original sheet. In this one, we want to multiply everything by the LCD. What's the LCD? Well, this is 1. So we have a square root of 3 and we have a square root of x plus 2. That is our LCD. Everything has to be represented. And so we're going to multiply everything that way. And over here you can see our x plus 2's will cancel. Here our x square root of 3's will cancel. And nothing's canceling down below. So I get the square root of 3 minus the square root of x plus 2 on the top. And down below, I have all that stuff. The square root of 3, square root of x plus 2, and x minus 1. None of that's gone, so it's still there. Now, same thing I did before, I want to multiply by the conjugate, and I have to do the top and the bottom. This is going to be the square root of 3 plus the square root of x plus 2. And then when I multiply conjugates, I only have to worry about the first and the last. Square root times itself is going to be 3. Square root times itself is going to be the radicand, which is x plus 2. Remember, it's a minus, so I have to distribute that through there. And then I have all this stuff. The square root of 3, square root of x plus 2, x minus 1, square root of 3 plus x plus 2. All right, let's go ahead and simplify that numerator. I'm just going to say 3 minus x minus 2. For now, I'm just going to write that I have a denominator down there. I don't know, I should have not written LCD, just D, something. I've still got that. And so what I get is 3 minus 2, which is 1 minus x. Now, here's the thing. In my denominator that I didn't write down here, but this is what I meant, I have an x minus 1. And up here I have a 1 minus x. So what I want to do is rewrite this. This is my denominator still. I want to rewrite this so that it looks like that. Then I could get rid of them. Right now they're opposite. See how x is positive, x is negative, 1 is negative, 1 is positive. So all I have to do is factor out a negative 1. That changes that to be negative 1, and it changes that to be positive x. I can change the order, but you look, if I distribute that, I get negative x and positive 1. Now, when I write that denominator, I can see that I can cancel the x minus 1 because I have the same thing on top and bottom. Holy cow. So those cancel, and I'm left with, my final answer is negative 1 on the top, square root of 3 times the square root of x plus 2 times that conjugate that we chose earlier that never went away. And that is what your answer is going to be. Yowza. Okay, let's go on. Factoring. Now, when we're factoring, I've got, this is number 4. I've got 2 different problems side by side here. um, we're doing something different. We are trying to take out what these two things have in common. And so one thing I can look at is number wise. This doesn't have, just has a 1, this has a 2, so there's no number in common. The next thing I look for is a standalone x. Well, there is at least one x in each of these, so I'm going to take the x out. And then they also both have an x squared plus 1. You take out the power that is the lowest power that's in there. And negative 1/2 is definitely smaller than 1/2, so I'm going to take out a negative 1/2. Okay. And then what I put in here is what's left when I take those things out. Okay. So I'm going to rewrite this x to the third, x to the second plus 1 divided by x to the second plus 1 to the negative 1/2. What you should see is that these things cancel, and I have 1x coming out, so I have x squared left. That's what I'm going to have left for that first term, right? Now for the second one, if I'm dividing by x squared plus 1 to the negative 1/2, then my x's go away. This is a plus, so I have 2. And then what I have is x squared plus 1 to the 1/2 minus negative 1/2, because when you have the same base, you subtract your powers, and minus a minus makes that plus, so we actually have x squared plus 1 to the first power, or just x squared plus 1. Okay, that's what I have inside there. I'm going to rewrite this way, and that is to write this as x, and then this, if I want to make that a positive exponent, I'm going to drop it down, and when I drop it down, then it becomes positive 1/2. Over here, so this was kind of just the work in the middle. Over here I have x squared plus 2x squared plus 2, and then I can add those two together. That gives me 3x squared plus 2. And so what I'm going to have on the top is x times 3x squared plus 2. And then on the bottom, instead of writing that to the 1/2 power, I can, but I can also write it as a square root of x squared plus 1. That's the same as 1/2 power. So that is what that one looks like. Okay, number 4E, we're taking out the same thing again. We're going to take out what they have in common, and I'm going to start by writing what they have in common over here. So 5 and 3/2, I'm not going to take anything like that out. There is a standalone x. The smaller of those is 1/2, so I'm going to take out x to the 1/2 power. And then I have x minus 1, and the smaller of those powers is 4, and then I want to figure out what goes in here. Okay, so I'm going to divide this by x to the 1/2, x minus 1 to the 4th, and I'm going to divide this to x to the 1/2, x minus 1 to the 4th. Because when you're factoring something out, you're actually just dividing by that. Okay, so this is just 5. And 3/2 minus 1/2 is 2/2. So you really have x to the 3/2 minus 1/2, which hopefully you can see that would just be 2/2 or x. And these are going to cancel out completely. So for this first term, you have 5x. That's what's going to go in your parentheses over here. Okay. Now for the second half, I have 3/2 and I have these canceling, and I have 1x minus 1 left over after I take out the, there's 4 down here and there's 5 up there, so I have 1 left. And now if I distribute that, well, if I distribute that, I get 3/2 x minus 3/2, right? 3/2 x minus 3/2. So I want to combine these two, and I know that 5 is the same as 10/2. And the reason I did that was so that I could combine these. I got the common denominator. So I have 10 plus 3, which is 13. And now I can actually take out a half, because there's a half in here and there's a half in there. So I'm going to factor out the half. X to the 1/2 is the same as the square root of x. I'm going to rewrite that as the square root of x. Then I have x minus 1 to the 4th. If I take out the 1/2, I'm left with 13x minus 3. Now, this is how I might write this, or you might see it as the square root of x over 2 times x minus 1 to the 4th times 13x minus 3. I think these are the same pretty much, but that's the idea right there. Okay, let's take a look at the next one. I have number-wise, I'm going to deal with that later. Okay, so I'm not going to deal with that. But I do have x plus 4, at least one of those, right? So I'm going to take the x plus 4 out, the first power. I know that I'm going to be dividing everything by x plus 4. And I also have an x minus 1, but what power am I going to take out? Well, you take out the lowest power. 1/2 is smaller than 3/2, so I'm going to take out 1/2. And I'm going to be dividing then x minus 1 to the 1/2, x minus 1 to the 1/2. What's left? Well, I had 2 of those, so I have 1 left. Make that I have x plus 4. I still have the 3/2. But x minus 1, 1/2, those cancel, right? And then I have x plus 4's cancel. I have 3/2 minus 1/2, which is 2/2 again. So that's just going to be the 2. 2. And then, what did I say? Those cancel, and I get x minus 1. Okay, so I'm going to, I can write that as, I'm just looking to see where I did this before. I don't see that I did it. Anyway, I can write this as a square root if I want. That's kind of, it looks like that's kind of how they're wanting the answer. That's going to be the square root of x minus 1. In here, I have 3/2 x plus 12/2. I'm just going to leave everything in halves because I think I'm going to factor that out in a second. 12/2, that's just 6, but this is x, sorry. And then I have 2x, which I'm going to write as 4x. No. 4/2x, sorry. What I have is 2x minus 1, but I'm going to write that as 4/2 x minus 2/2 so that I can factor that half out of there. I'm trying to get to where I have something that makes sense so I can take it out. And so I want to take out the half in a second. But let's add together what I have. I have 3/2 x and 4/2 x. That's 7/2 x. I have 12 minus 2, or 10x. I felt sure I worked this out before, but I don't see it on my scrap paper. Anyway, 12 minus 2 is 10x. I mean 10/2. Jeez. And so I can take out the half. And so I'm going to take this x plus 4 square root of x minus 1. I'm going to put that 2 out front, and that's going to give me 7x plus 10. All right, so that is probably how they want it written. It seems like they have a pretty specific way that they want that to look. What was that? 4f. 7x plus 8. How did I get 10? All right, let's go on. That should have been 8. So somewhere, hopefully you saw my calculation error in there. Oh, I know why. Because this 2 times 1 is 2, and so 2 is equal to 4 halves. And so I have 12 minus 4, which is 8. So it's 8 here. Sorry about that. All right. A little calculation error that hopefully you spotted before I did. Okay. What about this one? Well, I have x's. I have at least one standalone x in both of those. So I'm going to take that out. I have an x plus 1. Which power? Well, the smallest power is negative 2/3. And so when I take out the x and the x plus 1 to the negative 2/3, then I have, in the first case, I have one x left, so I still have that x over 3, but this goes away completely. And here I have 2, and I have 1/3 minus a negative 2/3. Do you see how that's plus 2/3, which makes that 3/3? Which is just x plus 1. So I have x plus 1. I can rewrite this as x over x plus 1 to the 2/3 power, right? And then what I get in here is x over 3 plus 2x plus 2. I'm going to write 2x. I want it to be like, well, 3, so I'm going to write that as 6/3. That's the same as 2x, right? And then I'm going to write this one as 6/3 as well. So that was 2. It was 2x plus 2, which 6 over 3 is 2. So I could replace that. Now I can combine 6x and 1x to get 7x. And I have 6 over 3. And I still have this stuff. So the last thing I want to do is take that third out. So when I take the third out, it's going to definitely be down here. And that's going to leave 7x plus 6. All right, so they don't ever want you to leave the common denominator in there. That would just come out as 1/3. And when I write it as 1/3 out front, I can just write, I don't need to put 1 up there because it's already understood that that x has a coefficient of 1. All right, and the last 3 problems ask you to simplify, and they're really complex fractions just like we did before. They're just a little bit in disguise. Look at the first one. This is what it looked like originally, and so when I'm thinking about that, I'm putting x plus 1 over the square root of x. 2 square root of x over 1. And this term over 1. So the common denominator here is really just the square root of x. So I'm going to go back and do that same method, multiply everything times the square root of x. But what happens for this one is that my x's cancel. And that's what I always want to happen if I can, is to get things to cancel out and simplify out. So then I'm going to get x plus 1 on the top for the first part. I don't really need parentheses around it, but I'm going to put that. What do I get when I take the square root of x times the square root of x? I get x. So I get minus 2x. And on the bottom, I get the square root of x times x plus 1 squared. And then x minus 2x is negative x plus 1. And square root of x times x plus 1 squared. That's all that is. Nice, huh? Let's look at the second one. I'm going to, this is how it appears. I'm just going to think of that as a complex fraction, and then I'm going to say I'm going to multiply by the LCD. The only denominator we have is this. So I'm going to multiply everything times 2 times the square root of x minus 1. Okay? And that means that on the top here of these square root of x minus 1 times the square root of x minus 1, when you multiply a square root times itself, you get the radicand. So I have 2 times x minus 1. Over here, the x minus 1s and the 2's cancel. Notice I have a minus in front of that, so I'm going to have a minus. That negative is going to have to distribute through, okay? I know I could simplify this, but I'm just going to leave it like this because I want to show you that I have one of those and I have 2 more. So you should be able to follow that I have then the square root of x minus 1 to the 3rd power, okay? Because I had 2 and I have 1 more. On the top, I get 2x minus 2 minus x minus 4. And on the bottom, I'm not going to do anything with that except I'm just going to write it as a little differently. I'm going to write that as x minus 1 to the 1/2 power instead of to the square root to the 3rd power. And then I have 2x minus x, which is x, negative 2 and negative 4, which is 6. And then the final way I can write that, because when you have a power raised to a power, you multiply. So you're actually multiplying 1/2 times 3, and that gives you x minus 1 to the 3/2 power. And that's what the final answer is. Okay, and this one, I've rewritten it already. This was x minus 1 to the 1/2 power. That's right there. The 1/3, well, the 1's on top, the 3's on bottom. And x plus 1 to the negative 2/3. When you have something to the negative 2/3 power, it's going to drop down in the fraction, and when it does, it becomes a positive power. The second one, x plus 1 to the 1/3, is up on top. This 2 is in the denominator, and x minus 1 is also going to drop into the denominator. Negative 1/2 becomes positive 1/2, and then the x minus 1 is going to be over 1. And now you're going to multiply everything by the LCD. The LCD, well, we have a 2 and a 3, so we're going to have an LCD that's got a 6. You've got an x plus 1 to the 2/3 power. And you've got an x minus 1 to the 1/2 power. Don't get lazy here. Go ahead and write down what you're actually multiplying. And it's easy just to go, oh yeah, I'll just do that right at once. But that's when people start making mistakes. So don't do it. Okay, so that's my LCD. That's what I'm multiplying everything by. Phew. Okay, so what happens to the first one? Well, 3 goes into 6 twice. The x plus 1 to the 2/3 cancels. So we have 2 times x minus 1 to the 1/2 power times x minus 1 to the 1/2 power, right? When I multiply these together, I have 1/2 plus 1/2, which is just 1, right? So it's just to the 1/1 power. Over here, 2 goes into 6 3 times. This is a minus, so I have minus 3. And then the x minus 1 stuff cancels. And I have x plus 1 times x plus 1. And I have 1/3 plus 2/3. That's 3/3, or that's just x plus 1. Now down below, it's this sort of nightmare thing. But what I have is 6. And I have x plus 1 squared. And I have, wait a second, was it x plus 1 was my LCD? X plus 1, oh, 2/3, sorry, yeah, 2/3. And then I have x minus 1 to the 1/2. So I got all that stuff. Oh, wait a second, x minus 1 and x minus 1. This was like to the 1st power plus another half. So that's like 2 over 2 plus 1. That's 3/2, right? So it's actually 3/2 because I had 1 and I had half more. So 1 1/2. Now that looks like 2x minus 2 minus 3x minus 3, and then all that stuff. And I call it denominator. And 2x x minus 3x. 2 minus 3 is negative 1. Negative 2 minus 3 is negative 5. And then I just have to write that one more time. I've got 6. I've got x plus 1 to the 2/3 power and x minus 1 to the 3/2 power. You know, it's just a matter of just going slow enough to take it step by step. And you can tell when I tried earlier, I made a mistake when I was kind of trying to hurry through. But mostly, if you see something like this, you want to take your negative exponents and get rid of them and make it into a complex fraction, and then you can work with it. Phew-wee. All right. We'll see you next time. Have